Alright, so today we will be learning about Form 4 Chapter 6, Linear Inequalities in Two Variables. So what is linear inequality? Linear inequality is an expression or expressions that contains two linear expressions and are compared using inequality symbols. I will touch more on inequality symbols in the next slide. And linear inequality expressions contain at least one algebraic expression. So over here, we are going to learn how to represent linear inequality. So these are the aforementioned symbols, or the way you present them. The arrow to the right is greater than, the arrow to the left is less than, the arrow to the right with a line on the bottom is greater than or equal to, and the arrow to the left with a line at the bottom is less than or equal to. So over here at the bottom, we can see some examples. The first example being y left arrow 3. This translates to y is less than 3, which means that y could be anywhere starting from 2 and all the way to the negatives, depending on the question asked and its parameters. The second example is x right arrow 4. This translates to x is greater than 4, which means that x could be 5, which is greater than 4, and could be anything all the way to the infinite numbers. On the third example, you have y equals to x plus 4. This means that y is equal to whatever x is plus 4 of that value. And finally, the final example, x left arrow with a bottom line 5. This means that x is less than or equal to 5, which means x could be 5 or anything less than 5. As an example, 4 or lower, or even 5 because it has an equal to sign. So this is the systems of linear inequalities in two variables. So this will occur when you have both a y and an x variable, basically two variables. It can be anything ranging from a or b depending on the question asked. So over here we will represent the two variables with y and x. So if y is greater than x, you would have the right pointing symbol pointing towards x. So as seen in the first line here, you will have y right arrow x. If y is less than x, you would write y left arrow x, whereby x is bigger than y. Y is not less than x, you would put y right arrow with a dash on the bottom, x. Y is not more than x, you would have y left arrow line on the bottom, x, etc., etc. And then finally, when there is another extra value, which in this case we would use k. So over here as an example, y is at least k times x. You would put y is greater than or equal to k multiplied by x. And if y is at most k times x, you would do the same equation, but you would flip the equation around, thereby making it less than or equal to. If the maximum of y is k, it will be y is lesser than or equal to k, because the maximum of y is k. And the same thing goes for minimum of y is k. Y will be greater than or equal to k because the minimum of y is k. That is the condition. And then you have the sum of x and y is greater than k, which over here as it entails, x plus y is greater than k because it's what is stated. Difference between y and x is less than k, so y minus x is less than k. Y is more than x by at least k, so y minus x is greater than or equals to k. Then we move on to verifying points that satisfy linear inequality. So linear inequalities can be described on a graph where it has a y-axis and an x-axis, y-axis being vertical and x-axis being horizontal. So as an example, over here we have x is greater than or equal to 1. So if we take a look at the left diagram, or diagram 1, you can see that the area shaded in pink is basically x greater than or equal to 1. As you can see, it's going to the right because it is greater than, so it's moving to the right of the x-axis. And then Diagram 2 is the fully expanded graph, where as you can see, x is greater than 1, so it encompasses the entire area, whereas it goes in ascending order 1, 2, 3, 4, and so on and so forth. So if you take a look at the star over here, the inequality signs greater than and less than are represented with dashed lines. If you take a look at diagram 1, that is an example of a dashed line, while greater than or equal to and less than or equal to are represented with solid lines. If you take a look at diagram 2, this is just an example. This doesn't mean that it's literally supposed to be a dashed line or solid line, but diagram 2 uses a solid line. Alright, so over here we have a few equations where we will learn to differentiate the region above and the region below. So on the first, second, third, fourth diagram, we have y equals to mx plus c on the first two at the top, y equals to h, and x equals to k on the bottom. So y equals to mx plus c is the general form of a straight line, where m is the gradient of the straight line and c is the y-intercept, or basically the point in which it intercepts the y-axis, which is the vertical line in the center of the graph, or to the left of the graph. So as we can see at the top, the region above is obviously the region above, and the region below is anything below the line. So same thing goes for the bottom. Y equals to h. The region above is everything above the line, and the region below is everything below the line. Y equals to h. Same thing goes for the x-axis, x equals to k, the equation, where because this isn't a y-axis equation, it will turn into left and right because x is a horizontal axis, it's not a vertical axis. So x equals to k, region on the left will be everything to the left of the line, and region on the right will be everything to the right of that equation line. So we are going to determine and shade the region that is stated by the equation. So if we take a look at the equation to the left, points that lie on the straight line satisfy the equation y equals to mx plus c, which is basically the form of a straight line. Points located in the region above the straight line satisfy the inequality y greater than mx plus c. Points located in the region below the straight line satisfy the inequality y less than mx plus c. So these are just general pointers and guidelines. So over here to the right, points that lie on the straight line satisfy the equation y equals to h. Points located in the region above the straight line over here satisfy the inequality y is more than h, and points located in the region below the straight line satisfy the inequality y less than h. We are going to be determining and shading a region with two systems of linear inequalities. So often in questions, they will give you two equations in which they want you to shade. So first of all, you have to plot the lines. So over here, we have to plot the lines for which are already given, but I will reiterate on how to plot the lines. So we have to plot y equals to x plus 3 and x equals to 2 because of the equation given above, which they want us to shade, which is y less than or equals to x plus 3 and x is less than 2. So we will start with y equals to x plus 3. So in order to get the plot points on which the line should be drawn, we can replace y or x, depending on what we are trying to look for, with 0, and do the equation until we get y equals to something or x equals to something. So in this case, we can do, if we want to look for the y-intercept, we can do y equals to 0 plus 3, where we replace x with 0. So the reason why we're replacing it with 0 is because when it intersects at that point, if you take a look at the given example over here, number 3 is an intersect where it intersects with the equation line, right? The straight line. Is because when it intersects with the y-axis or the x-axis, the opposite axis is always 0. When it is over here at 3, it is 0 over here in terms of the x-axis. When x is negative 3, it is 0 in terms of the y-axis or the vertical axis. So we can just replace the one of the unknowns with 0, y or x, and get it to, and we can get the value of where they would intersect. So in this case, if we should look for y first. So y equals to 0 plus 3, we would get y equals to 3. We would get y equals to 3. So the point of intersection is at 3 for the y-axis or the vertical axis. And when we look for x, y will be replaced with 0, and it will become x plus 3 equals to 0. And if we move plus 3 over to the other side, we would get negative 3 equals to x. So x intersection point is at negative 3. Therefore, we get this line. So with these two dots, you just have to take a ruler and draw a straight line, and you have your equation line. Then x equals to 2 is just a dashed line, if you recall from before, straight down the x-axis. Now we move on to shading. Y less than or equal to x plus 3. This line, this diagonal line, is the equation line. If the value is if y is less than or equal to, where would it be shaded? So if we shade it at the bottom, y would be less than 3 because it's shaded at the bottom, so it's constantly going below. So if we take a look over here, it will be 3, 2, 1, 0. Over here, negative 1, negative 2. So the correct answer should be shading the bottom, the entire area. But let's just take a look at what it would become if we shaded the top. So if we shaded the top, the value would be 3, 4, 5, 6, 7, etc., going higher. And that wouldn't be correct because y is less than or equal to x plus 3. And unless x is 0, there's no way it would be greater than or less than. So this is wrong. This should be if it was greater than or equal to. So let's take a look at the answer. So this is the part of y is less than or equals to x plus 3. So the shading was correct. You're supposed to shade the bottom as, once again, it is less than or equals to x plus 3. So it will always be below 3. Then we have x less than 2. So for x less than 2, we can once again take a look at the graph and see that it is plotted directly on 2. So if we shade the right side of the graph, it would be 2, 3, 4, 5, and it wouldn't make sense because x is supposed to be less than 2. But if we shade the left side of the graph, we would get 2, 1, 0, negative 1, negative 2, negative 3, which is correct because x is supposed to be less than 2, which means that it shouldn't be over 2 and 2, which is why we put the dashed line, which indicates that it is less than or greater than. The correct answer should be shaded to the left, as shown over here. So everything to the left is shaded 1, 0, negative 1, negative 2, negative 3, and so on and so forth. Then we have to combine both of these shaded regions together because the question asks us to look for both equations at the same time, or rather to shade and determine both equations at the same time. So the final result will look like this, where you take the intersecting point of the first equation and the second equation, intersect each other, and have the same area where it was shaded, and you just shade the area, and that is your final answer.
Hello, my name is Ahmad Lutfi Effendi bin Ahmad Ramzi from Group 1, and today I'll be discussing example questions for the subject Linear Inequality, Form 4, Chapter 6. So, for the first subtopic, representing linear inequality, we will be discussing questions to express the sentences into algebraic expressions. So, let's start. Write y is less than 60 plus x in algebraic expression. So to do this, we write y is less than, so we write less than 60 plus x. So for this, it will be 60 plus x. So let's move on to the next one. Write x is more than or equal to y. To do this, we do x and then more than or equal to, so we will write more than or equal to y. Next, write x is less than or equal to 50 minus y. X is less than or equal to 50 minus y, and this is some ways to represent linear inequality in algebraic terms. Alright, now moving on to systems of linear inequalities. Here we will see multiple ways to phrase more than or equals to with different words. So we must use these systems to express them in algebraic expressions. Let's start with the first one. y is at least 35. So y for at least, it means that the smallest number is 35. So y is more than or equals to 35 because y is at least 35. And it could also mean y is more than 35. Next, express x is at most y plus 90, meaning x cannot be more than y plus 90. So this means x is less than or equal to y plus 90. Sum of y and x is more than k. This means when y plus x, it is more than k. Alright, let's move on to the next one. Verifying points that satisfy linear inequality. Here, we will identify regions that satisfy the linear inequalities. Let's read the question. Based on the diagram, determine the region that satisfies each of the following systems of linear inequalities. Let's do question A. Alright, so let's first take a look at question A. Here we see y is less than or equals to 6. When it's less than or equals to, this means that this is a solid line. If it is a dashed line, it means it is only less than. So, let's see. Y is less than or equals to 6. We look at this 6 on the y-axis. It is over here. So when it says it is less than, it is underneath this region. Next, we see y is less than or equals to x. So when y is equals to x, it becomes this diagonal line right here. And since it is also equals, it is a solid line. Next, it is less than. So this means that this shaded area is down here. Since so far we've recognized that y is less than or equal to 6, and it is less than or equals to y, meaning this area right here is not covered, but this area right here is approximately where the region is. Next, we see x plus y is more than or equals to 6. When we see a question like this, we look at both the x and y axis and where that line intersects, where they both intersect the 6 points, the 6 location. So we see this and this. So this line is over here. When it says it is more than or equals to, it is a dashed line and it means that it is within, it does not cover this area because it is more than. So we can see that the region that this covers is region E. Let's try another example. Question B, y is less than or equals to 6. So that means it's down here. Y is more than or equals to x. This means on this diagonal line, it is around this area. And x plus y is more than or equals to 6, meaning that it is above this area. So we can see that the region specified is region C. Alright, next, y is less than or equal to 6, so it's down here. Y is less than or equals to x, meaning it's down here. And x plus y is less than or equals to 6, meaning it is beneath this. So the answer to this question is the region A. And finally, for question D, y is more than or equals to 6, meaning it is above here. Y is more than or equals to x, meaning it is above this line. And x plus y is more than or equals to 6. So it is above this region. So the only answer to this is region D. Excuse me. A. Alright. So let's move on to the final slide. Determining and shading the region. Here we will determine the region and shade it just like the question before. Except first, let's see the question. Shade the region that satisfies each of the following systems of linear equations. So we will see that y is more than or equals to 2x minus 4, x is more than or equals to 0, and y is less than or equals to 0. So y is less than or equals to 0, meaning it is down here. x is more than or equals to 0, meaning it is around this area, and y is more than or equals to 2x minus 4, and that is the linear line we see right here. When it says it's more than, it means it is above. So this is the region that satisfies this equation. Let's move on to the next question. Y is less than or equals to 2x or 2 over 3x. Sorry, 2x over 3 plus 4. So this will be the line over here. X is less than 3, which is the axis over here, meaning it is on the left side. And x is more than 0, meaning it is more than this area. And y is more than 0, meaning it cannot be under this area. So this is the region that is from the question. Alright, that is all for the examples. Thank you very much for watching. Please like and subscribe. Thank you.